Okay, folks, we're going to go back now to the calculus question. By the way, the calculus question was given to us by Puleng. Puleng, we've done the first half of your question. We're now going to look at the second half. What do we have? We have a function f, which is a cubic function. Excuse me. Then we also have a linear function g. They intersect one another at a and b. B is the y-intercept of the line and of the cubic. And A is the x-intercept of both the line and of this cubic curve. D is another x-intercept that they gave us, but D is also, with C, a stationary point for this cubic curve. Now, look at what they've given us here. They told us the root of multiplicity 2, which is this one, the one where the curve touched the x-axis, has coordinates 2 and 0. So we've got that coordinate pair here. We also have the coordinate pair at B. It is the y-intercept of the line. So this will be the point 0 and 12. Now, folks, look at it. That is the first question that they're asking us to find. So we've answered the first question. The coordinates for B is indeed 0 and 12. Okay, now they want us to go and find the coordinates of A, this point where the cubic cuts the x-intercept, or the x-intercept of the cubic. Or you can think of it also as the x-intercept of the line. Now, we've got to be careful here. To find that x-intercept, we need to go to the graph where we have the most information. And that graph definitely could be either the cubic, which is f of x, or it could be g of x. We need a m here, and we need a k over there. Okay, so let's have a look. If we want to find the m, the x is 0. And then we just get 12 equals 12, so it's not really going to help us. Let us go to the cubic. Let us say that because we have point B, we know that f of 0 is indeed 12, seeing that we are trying to find the x-intercept of the cubic. So let's work with that. From here onwards now, we make x 0. So 12 is equal to minus 2 all squared is 4. 0 minus k is minus k there. So our k is equal to negative 3. And that's all we wanted. That is the other factor, folks. So if we now go to the factor here and we say x minus 3, that is the factor. So this becomes x plus 3, which means the root lies at the point minus 3 and 0. Okay, so A is the point minus 3 and 0. Let's go down. There we go. Now we've got A. We've got the other x-intercept. We have both x-intercepts. The only other thing they can ask us is for the turning point, C. Well, let's see if they do. If k is minus 3, okay, so they're confirming that we did indeed do that correctly. Now, let's just say in an exam, you found k to be 2, folks. Don't go back and fiddle with number 2, okay? You will get a mark for the substitution. You won't get a mark for the correct answer, okay? Just use the k value then that they gave you to go forward with the problem. So they said k is 3. We put the k equal to 3 in, and we're now going to find the coordinates for C. So what do we know about f of x? We know that it's equal to x minus 2 squared times x plus 3, and that becomes x squared minus 4x plus 4 times by x plus 3. Why am I multiplying out? Because I have to differentiate to get to C. it is a turning point or a stationary point. We know the derivative is naught at stationary points. So I need to find out what f of x is. So if I multiply the x in, I get x cubed minus 4x squared. Now do this slowly. You don't want to make a silly mistake here. Plus 3x squared minus 12x plus 12. We have x cubed minus x squared over here, if I add those two, minus 8x plus 12. Okay, so I've checked and we are 100% correct with our multiplication over here. So now we've got to differentiate and make this equal to 0. Why? For the stationary point. Okay, if I differentiate that, I get 3x squared minus 2x minus 8, which is naught. And look at this, I'm going to cheat. I know that this is one of the factors x minus 2 because it is a stationary point. So I'm going to x minus 2 that. Then I say, oh, okay, to get 3x squared, I need 3x. To get minus 8, I need plus 4 over here. Let's see if we were right. We get minus 6 plus 4 is minus 2. That gives us minus 8. Voila, we are indeed correct. And remember, they only asked us for C. So we can now say the x coordinate for point C is this minus 4 over 3. Is indeed the x coordinate for that point. Now, folks, we all have calculators. To go and find the y coordinate for C, you just go to your function and wherever there's an x, you substitute minus 4 over 3 in there. Work slowly. You're going to get a very weird answer. In fact, your answer is 500 over 27. So just answer their final question. Tell them the coordinates for C is minus 4 over 3 and 500 over 27 for the point C, the turning point. Okay, so remember how I crooked? The moment it touches the curve, it's a root of multiplicity 2, meaning it's an x-intercept as well as a turning point. Okay, now they ask us, let me just see if I've got my next question on that. No, let's just quickly finish this question. They ask us the values of C for which this function is concave downwards. Number 3. The value of x such that f is, what did they say? Concave downwards. Now, folks, you should study this off by heart. If something is concave downwards, its second derivative is negative. N for negative, n for downwards. That's how I remember it. Upwards, p for up, p for positive. Okay, it's a good way to remember that. So we just need to find out where's the second derivative negative for which value of x. Now we've already got the first derivative, it's over there. So this is where 6x minus 2 is indeed a negative number. And what is that x value? 6x is less than 2, so therefore x is smaller than a third. So on this graph, if x is smaller than a third, it is concave downwards. N downwards, okay? Negative second derivative.